Hi, this is Tom, and today we're going to tackle the problem of dividing fractions. And so it all begins with this. Let A over B and C over D be fractions. Find, this is what our goal is, we're going to find what is the result of A, the fraction A over B, divided by the fraction of C, divided by the fraction of C over D. In order to do this, we need a few pieces, and so that's what we're going to do. So we need to recall a few properties. The first property is this, and that is that, for example, a number n can be written as the fraction of n over 1. And so we'd write this mathematically, so what we would do is we write that n is equal to n over 1. And so now you can use those interchangeably. And you've probably done this before. For example, if you were given the number 6, you could write that as the fraction of 6 over 1. Okay, that's our first thing. And we've explored many of these, but it's always a good reminder. The second one, and oh, I should have put in here, this holds true except for n equals 0. So that's other than that. Next one we want is, well, let's try this. Take any number n, divided by itself is always 1. And again, except 0. So what this means is that if I take the number n and I divide it by the number itself, n, I always get the number 1. And we've also seen this in forms like this. We may have written it as n, oops, let me go back and write it. You may have written it as n divided by n. Well, that's just 1. We could have used some specific numbers. For example, 3 over 3. Well, that's just 1. Now, let's try something maybe not so obvious. Say we have a number, but this time our number is a fraction. Like, say we have the fraction of d over c. That's my number. Then that means that if I have that exact same number, d over c, in the denominator, well, even though it looks like a large piece, it's still just a number divided by itself, and we can say that that number is just 1. Now I need some more real estate here, so I'm going to try this. I was practicing this a little bit ago and I was having some difficulty, but I think this will work. And I wanted to cut that. Now, let's see, I need to go back and I want to paste it, and I want to resize it. And let's make it a little bit smaller so we still have some space. We're going to move that up here so that if we need it later, it's still at our disposal, and now we can keep going. Now the next thing that we wanted, and we'll call this property 3. And property 3 says this. I'm going to write it over here, and I'll move it over there in a moment. Property 3 says that if multiply multiply any number n by 1, the result is n. So let's try this with the words. The words would have said that if I take the number n and I multiply it by 1, well, the result is just n. And you could try more complicated ideas, like maybe some larger numbers like 3. If I multiply 3 with 1, I get 3. Or it even works. Let's try something more difficult. How about something like this? Here's a number that most of us aren't that comfortable with. It's the number pi. It comes from parts of a circle, but pi, if I multiply it by 3 over 3, well, that looks kind of intimidating, but if you recall from what we did just a little bit ago, we said that 3 over 3, that's just 1, and we can use that property. And so now this is the problem of pi times 1. And we know that pi times 1 is simply pi. So that's the next piece that we need. Any number multiplied by 1 is just any number. So I'm going to put that little piece, we're going to cut that, and we're going to resize it. I'm going to move it down here. And now I think we're ready to move on. Our fourth piece is this, number 4. Number 4 says that if I take a fraction, for example, say I take the fraction of a over b, and I want to multiply it by some number. I'm not quite sure what that is, so I'm just going to put a box here. We'll figure that out in a moment. But I want to multiply this a over b times some number, and that's going to give me a fraction, but I want a specific result. And the result that I'm after, again, is back to this idea of 1, I need a 1. Well, let's look. We already have an a and a b in the problem. And we said that back in this problem over here, let me grab a different color. We said this. We said that if we can get the number over itself, we know the answer is 1. Well, I have a b in the bottom, so I probably need a b in the top. I have an a in the top, so I probably need an a in the bottom. In other words, this piece that we've just uncovered right here, this is what, this right here is what goes back into the box. And so if we take b, a over b, and we multiply it by b over a, the result is 1. And this is actually a very useful property, and it says that a over b flipped to b over a and multiplied is 1. And we have some more that comes from this. And when you the flipped fraction, the flipped fraction is called the reciprocal. It's called the reciprocal. So we would say that b over a is the reciprocal of a over b. All right, we're almost ready. We're almost ready to put all of this together. And I think let's just use our intuition to develop the idea one more time. And so again, I'm going to make this just a little bit smaller, and we'll reference it as we need it. I needed to resize that. And if I do this, we'll just move it down, and we'll put it up here. And maybe move it down a little. that looks about right. So now I think we're ready. Our next step says this. Our next step is this. Let's try a problem we've done before. We've taken a number 6 and we've divided it by 3. And we've also said that this is the result of 6 divided by 3. And the answer we've learned before is 2. But it's not the answer that I'm interested in. It's the process. It's the process. So let's come back. Let's go to the 6 over 3 for a moment. And notice that 6 over 3 is the same as 2 times 3 over 3. Now, also, we said this. We said that you can take any number and multiply it by 1. For example, we used a perfect example of it right here. We said that 3 is the same as 3 times 1. So let's utilize that. Let's do that in both the numerator and the denominator. So if I take this as 2 times 3 times 1, and I make this 3 in the denominator, I'm going to write it this way, a 1 times 3, look at what I have. This is the fraction of 2 times 3 over 1 times the fraction of 1 over 3. But this is 2 times 3, well, that's 6. And 6, we said earlier, can be written as 6 over 1 times 1 over 3. And I think we might be on to something, and here's what my suspicion is this. Notice here we began the right half of the problem with division and 3. But down here, what did we end with? We ended with multiplication, and not a 3, but the reciprocal of 3. So that's what I'm wondering, is that maybe division is just multiplication by a reciprocal. Well, let's return to where this whole problem began, and it began with the problem of, here we go, it began with the problem of A over B divided by C over D. So what we said is this is the same as, well, remember how when we took 6 and we divided by 3, we said that's the same as 6 over 3? Well, that's the same as A over B over C over D. But what we want to do now, and we're going to do this by design, is we want to come up with some version of 1, because remember, 1 doesn't change a value. All it does is it just changes the appearance. And what we also said is that if we multiply by a reciprocal, we can get 1. And if we can get 1 in the denominator, then the numerator is the result. So if I multiply the denominator of C over D times its reciprocal of D over C, well, that's going to give me a 1 in the denominator. And that's what we said right here. Okay? Using that, then that means to make this a 1, the numerator also needs to be a D over C. And when we multiply this together, we have the fraction of A over B times the fraction of D over C. And in fact, that is our answer. We would say that A over B divided by C over D is the same as A over B, whoops, sorry about that, times D over C. So what we did is we did two things. The multiplication became division. The multiplication becomes division. I'm sorry, that's completely wrong. We said that the division becomes multiplication. I'm going to abbreviate, and we multiply by the reciprocal. Multiply by the reciprocal of the second fraction. And that's what we did here. Our division became multiplication, and our second fraction became its reciprocal. All right, so I think we just have time for one last, we'll call an application. Let's try one last application. And let's try something like the problem of 1 and 1/3. And we're going to divide that by the problem of, how about 2/5? 2/5. So, well, remember that this is a mixed number and we've been studying fractions, but the first step is to recognize that a mixed number is also a fraction if you think of it as a 3 times the 1 plus the 1 over the 3. Then we still have our divided by 2/5. And then our result, this becomes 4/3. And then our multiplication changes, our division changes to multiplication, and our second fraction becomes its reciprocal, 5/2. And notice that 4 is 2 times 2, so let's think of this as a moment as 2 times 2 times 5 over, and I'm going to switch, or we'll do this, 3 times 2. But you can reorder this as 2/2 times 2 times 5/3. And if you go back to where we were earlier here, we said that a number over itself, that's just 1. And so if we utilize that, we have 1 times 10/3. And that goes back to what we said in step 2, that a number times 1 is just the number. So our final result is 10/3. And that's how you divide fractions. This is Tom, and thanks for watching.